Hello friends, welcome back to my channel. In this video, we will try to learn about timers. How we can make timers for long value, for example hours, days and by months. How much a long timer how we can made in PLC programming in Allen-Bradley. So first of all I open my software RS Logix 500 and then also make it RS Links Classic. Because of this communication software we have to be check our communication is okay or not okay. It's running. Make it configuration auto configure successful, okay, and close. Scroll down and let's start. I will open any program which is in a and that's old program. I will delete and we will make a new program. So let's start. First of all, what we will do, first we take one input contact from where we like to start our program. Input address I:0 I:0/0. I will take my first input of the PLC. First input of the PLC, and second we take one timer. T1 on delay, and that's will time give him T4:0. T4:0 we will take for 1 second, and this value we will later on fix how much value we like to, how much seconds. For example, if we make a 1 minute, we will put it here 160. Because of this is 1 second timer, we need 60 value. After 60 seconds after he change his contact. In the second row also we take one contact for one counter, for example, and next I will take also a one counter, CTU counter, and this I will take C5:0, and value how much you like to take, minutes, 4 minutes, 5 minutes, 6 minutes, that's depend on you. This we will later on fix. And this counter I will run by in sequence. If we will make, wait, this is also I will make it one timer, TON timer, because when sequence will be running, this also T4:1 I will take, because when sequence is running, after you better understand. T4.1, and this will be, we will run from counter, and here we will take one more bit we will take, and once we will complete this all bits, now we take for counter, one counter and one counter more we will take. Here, and one more counter will take. Why I take this two counters, I will explain you with a minute. And in next row, so first this complete, this is my first input for to execution the program, and here one take I will make a contact for close contact for this timer T4 colon 0 T4 colon 0 slash done. I need when I make it this execution, that timer will be started, and this is personally when time is, which time we will set it here. After when time completed, after this will be automatically make it reset. Yani we need only 60 seconds or 80 or 90, which time you like to be make timing. Calculation formula is 60 seconds for a 1 minute, and 60 minutes have a 1 hour. So we will put this one 60 seconds. This is calculated 1 minute, and this timer we will make for reset to our counter. C50 I will use this counter. How much value I will use this one? C5 column 1. C5 column 0. This counter I will take for this value when T4.0, which value gives this, we will count it here, and this counter we will take for C5 colon 1. This we another value, this is for our bits, how much release we will like to be start. So this counter will count the release how much, and this counter will be count the time. Because of how we have to be decide how much release or how much contacts we need to be on and off with time, this we have to be decide, and time also we have to be decide how much time for we one relay need to be run. So first this C5 colon 0, this we will run by this timer, run by C5 colon 0. C5 colon 0 slash done. When this is done, after this timer, this counter and this counter we will need to start from this T4 colon 0. T4 colon 0 slash done. Right, and third this one, this our counter we need to be run by C5 colon 0 also. C5 colon 0 slash done. When this our counter have been done, this also we run from this C5 colon 0, because of when counting is coming here, after this counting are completed, after we need it here one count, first relay for example we need to run, and this is how much time we need to be run. For example, I will put it here, for example 4 counts after one count completed. Because of C5 colon 0, I need this counter I done by this counter, because this is the time and this is our relay. And next we will take the commands of which relays we like to be start. Go to the compare command, and that's the we will use equal command. That's the equal command, and next we take for bit. For example, this C5 colon 1 dot acc, and this our B3 colon 0 for example slash 1. For example, this B3 colon 0 slash 1, I need that this B3 colon binary bit B3 colon 0 first bit I need to be on, same as this Control C, and I will make this copy. V. How much you need? You can make it copy down. I'll copy the 4, but here I will be change. Source A. When here countings are completed, for example, this 4 relays I will make, I will count it hit for 4. When my first relay ons, for example, this here is event 0, here is event 0, so I need my B3 colon 0, 1 bit need to be on, first bit, and here when is 1, for example, I need it run here second bit, 2 number, and when here is it completed 2, for example, I need it here 3 number relay, and when here is a completed 3, for example, and I need my 4 number bit on, here I will make it 4. So this area is completed now. Because of we like to be 4 relays in sequence need to be run from B3 0 colon 1 from to B3 0 colon 4. Means this B30 is file number. This is our basic relay number. Number 1, and you can think from forward या contactor or relay 1 number, 2 number, 3 number, and 4 number. And we need this procedure will be continue after completed at 1. Repeat the cycle. How can repeat the cycle? This we will make in next program. See, this is our complete. This our timer is complete, and this is 4 complete. Okay. Now we will make one here new bit for this one. Make resetting yani T4.1 this timer. When this timer is completed, I need to reset my this counter C5 colon 0. T4 colon 1, T4 colon 1 slash done. When this timer is done, I need to reset my counter C5 colon 0. Because of this C5 colon 0, when completed his time, we need to be stop, reset, make it back yani. Okay, and here one more we will take the bit C5 colon 1, because we relay also have to be need to change the contact when this C5 colon 1 is have completed his cycle, means number 4 when relay is complete, after this also needs to be go back. So what's the procedure? When this is comes at the 4, after this have to be this counter have to be personally goes to reset condition for repeating the function. And here take it one more bit C5 colon 1 slash done. After we need the reset C5 colon 1. Sorry, this unlatch coming. This we don't need unlatch. We need the reset. Go to the timer counter and make it reset C5 colon 1. So and one more thing, this counter C5 colon 0, we make it reset from T4 colon 1, but I need this also from this C5 colon 0. This is our counter. This counter also I need to be reset, because of this counter not reset, after this time will be increasing, but our contact will be no change. So one more I will take that C5 colon 0, also I make it one branch here. Go to here this one and bit user and make it one branch here, and here take one contact more of C C5 colon 0 slash done. Because of when this is counter completed, also I need to be reset this one counter. So now almost our program is like to be completed, but must we review the program? This is our input for execution the program, and this is our pulse, for example, to making a 60-second timer. When this is continuously on, when time is preset value will be completed, after it's done, after again it will be make it reset. Look like this will be continuously running, and after this C5 colon 0, this counter when done, after our one timer will be start, and this timer we will give the value for this is 1 colon 0, this is 1 second timer, and this value we will give for 2 seconds, because of when 2 seconds after this needs to be change his contact. When this timer will be running, after 2 seconds it will be reset this, it will be reset this C5 colon 0 timer, this one. And then T4 colon 0, this is the counting of our first timer. Here is we put 4 counts, for example this is 5 6 any we can put, and this is our counter is for our relays, how much relays we like to be operate. We decide 4 relays we have to be operate, number 1, number 2, number 3 and number 4. And number 4 when it's complete done, after we need this T4.1 timer also reset the C5 colon 0, and C5 colon 0 also reset this one, both will be reset. This one or this one which will be done, this will be reset, and this C5 colon 1 will be used for this our bits reset, how much this number 4 when completed it will be make it reset, because this C5 colon 1 dot ACC, this 3 we will decide when 3 is completed equal with 3 this one, this counter, after this will be go to back, make it reset for means. So let's download to the PLC. The common download, asking for saving the program. Now we have to be, but first this bit I will change back, we have to be hold, for example this one. See, when I give the signal I colon 1.0, that first bit when I make it on, my timer is now started. But this is very long timer, because of this we decide for 60 seconds after 1 minute completed. And here this counter also we decide 4 when this is completed for 4 minutes, after this will be completed. This is our time for this our release. Yani this is, for example this is our first bit is now on, because of our this C5 colon 1, this counter is now equal with 0, this equal command is equal with 0, this our first bit is now on. I will reduce this timer plus this one 60, in next we will complete for 5, for example fast we can say, after video will be go lengthy. This is 5 pulses after complete change his bit. See, now here is a completed 2, 3. When it's completed 4, after here is a count 1. See, now this time is completed yani, and here is a count 1 coming. For means yani 1 minute of our time is completed, it's change his contact. Now it's go to the second bit. As it's completed here 2, after it will be go to the next. When, because this equal command we used, that C5 colon 1 is equal with 2, after B 3 colon 0 will be 3 will be number 3 on. And when this is will time will be completed, after our 4 number will be on. Now our 4 number is on. And when this 4 number time will be finished, this will be make it this T4 colon 1, and this C5 colon 0 and C5 colon 1 will be make it reset to this bit, this counter. After it will be go back to 1. See, now also repeat, go back. This is now C5 colon 1 is going to reset, and this bit will be start again. So this procedure will be continuously repeat, as you not remove the signal from this one I1 colon dot 0. This first bit, when you, this can be emergency switch, can be your on off selector switch, and you can make also, you can one more bit if you like to make it here switch. This, for example, this is the emergency, and you have to make it here for one more bit for on start stop start function. This here you can fix, and this timer will be continuously. I hope you understand about this timer accumulate, how we can make the long timer. And this value you can increase if you like to make your 1 minute as a 60 seconds. When 60 seconds are completed, after your 1 count will be increase it here. This is I put 5. Why I 5? Because of this is fast will be completed after you understand. See, this is, this counter will be counted, this value of our timer, this 4.0 timer. This value of timer is counted here, this 4.0, this 4.0 timer, and this 4.0 timer counted here, counter 1. And as there is a 5 completed here, here is a 1 count will be increased. That's C3. I will make also a little big to you understand. See, it's now equal with 1. Because of this 5 pulses are completed. Now it's 2. When 5 pulses are completed, it will be 3. And when this completed 4 minutes, for example, this we think for 4 minutes. When this 4 minutes are completed, here is a 1 signal coming. When 1 count is came here, after our equal command will be work, and our bit will be on. And you can see after when this 5 will be completed, after here will be come 3. See, now this 4 counts are completed. After, if you like to make it fast, for example, I will make it here 2 seconds, 2 minutes. Think about this is the 2 minutes. It's changes contact for after 2 minutes. When it's completed here 4, after this will be fast go. See, now time is going to fast. When here is coming 2, after our this equal command works, and bit number 3 will be on. And after this B3 colon 0, 1, 2, 3, 4, here you can make another rows, and you can make your physical output address, give the output address. For example, I will make for you, and see, stop the communication, go offline, and simply here you can take the contacts, open contact, and output take B3 colon 0, B3 colon 0 slash 1. This first bit, because of this first bit we need the output of our PLC, and here you can give the address out colon 2 slash 0. First bit, for example, you need, this is your first bit, 0.0 will be on. And same as you make it control C, make it control V, control V, control V, and this is, you can change the address it here, B3 colon 0, and what's the address of our this bit 1, from 1 to 4. This is from, this is 1, this is you can change 2, this is you can change 3, and this is you can change 4, because of this is your last address of this bit B3 colon 04. And here you can change also, this is you 0 first bit you can on, here you can 1 number, here you can choose 2 number, here you can choose 3 number, and your this 4 bits will be on. And again download to the PLC, and this is your final address, yani out, this is output of your PLC. Here there you can fix your output, any contactor or whatever, and make the execution on, make the execution on, and now your output is on, first bit out 2 colon 0 is on. Now when time finished, after your second bit will be on. Here is we put 4, this is we put 60, because of the 60 seconds are too much long, we will put it here 5. After this will be fast will be changes contact. Now you can see here, go to the down, this is your first bit on, now your second bit is on, now your third bit is on. Now wait for 4 seconds, we decide for 4 minutes look like, yani this is 3 number, but this is number is 4, because this address are started from 0. 0 count in computer language, 0 is counted for 1. Now our 3 number bit is on, and when this will be complete time, after this will be goes to out 2 colon 0, our first bit. It will back to be 0. See, okay. Now this program is running for in sequence. This can be, this outputs can be a pump, can be a water pump, can be a motor, can be a conveyor, or any for example this can be a light pole, and for example 4 poles should need to be run, after you sequence wise need to be run, other can be a road signals also. This first signal you are open is, this is 1 road, this is 2nd road, this is 3rd road, this is 4th road, and after repeat to 1 road, and in after this output you make it a next program for how much any, this is 3 signals, red, yellow, blue will be needs to be on this in sequence, that will be continue runs in the sequence. So I hope guys you understand about this program. If you like this one, please like, share and subscribe my channel. This way you will be never miss my upcoming videos. I will share with you lot of programs in different logics. This time you can increase 60. Formula is this, and means 100% you can see 60 seconds equal with 1 minute, and 1 minute equal with 1 hour. If you need a 1 hour, for example, you can set it here time 1 hour, for example you need, you can put it here 60. When this will be 60 counts completed, this is when 60 completed, here is a 1 count completed, because of T4 colon 0 we are using for counter C5 colon 0. When here is 60 60 that bits completed. After here your one cycle completed means 1 minute. And if you need for hour, you can multiply by 60. This how much coming. So after this your 1 hour, 2 hours you can multiply by this also formula, and you can this your pumps will be running after this time. So thanks for watching. Allah Hafiz.